So we're going to kind of slowly go through this process of getting set up with NoSQL, but it's a good idea for us to have an idea of where we're going with it. Okay? So basically, NoSQL was a response to a problem. So the issue was when we built complicated relational databases, they were very hard to scale when our application demand grew quickly. So it was kind of developed as a response to that. So the idea that we've done before in relational databases, we have this, all our data, it always basically looks like this. Doesn't matter what data we're storing, students, orders, products, social media posts, everything's simply stored as rows and columns. So we use that same structure all the time. The problem is when we then go to write our applications, we typically have to write a lot of code to actually map this kind of grid-like structure to how our application looks. Now, when we used ASP.NET, that's what we used the entity framework for. It kind of took care of some of that object relational mapping. So getting the data and our application code to kind of talk to each other. So it's not very flexible. If we need to add a new column, we've got 4 columns in this table. If we need to add a 5th column, all of a sudden we've got to make a whole bunch of changes in our application code as well to account for it. So this model, it's powerful, but it's extremely inflexible. So the idea of NoSQL was to look for something more flexible. The idea really was instead of using tables and rows, what we have are sort of similar constructs, but they're a lot more flexible. So instead of tables, we have collections. And instead of a record, we have a document. So most documents, all our documents typically are in JSON format. So just like the examples in the video, it could be just a set of keys and values, but we can also have nested or related data inside of one of these documents. So this would be one document. This would be considered a separate document. So a document is like a record. Okay? I'll try and use the NoSQL terminology. I'll try to use the terms collection and document rather than tables and records, but they mean similar things. So they're schemaless in that, as Mackenzie said, each record or each document, it might look slightly different. It might have different values or different fields from other records in the same collection. Okay? One of the other nice things is we can just evolve this over time. So for example, let's say we've got a table with columns first name, last name, and email in a relational database. And suddenly we want to store someone's phone number. What would we have to do before we could add a new record? We'd have to do something first. So we got 3 columns, first name, last name, email. And now we want to add Carlin to the database, but we figure we actually would be a good idea to have his phone number as well. What are we going to have to do before we can save it? Yeah, we're going to have to go and modify the structure of the database to add a column, add a place to put that phone number in. One of the great things about a NoSQL database, we don't have to do that. Because there's no schema defined, we can just add in Carlin's first name, last name, email, and phone number, and that phone number automatically gets saved. We don't have to pre-allocate a space for it. We also can nest one document inside another, so all of the data related to something lives in one document. It's not pieced together throughout the database and related with foreign and primary keys. So because it scales, it also is perfect for cloud hosting solutions because the idea of the cloud is our cloud services scale automatically. So our database structure can scale along with the environment. So this is what a typical document would look like. So think of this. This is the equivalent of one record in a relational database. Okay. So this would be stored in a collection. So notice everything is key value pairs. So all of the keys are in quotes and all of the values, well, the values in this example, they are all in quotes, except if they're numbers, they don't have to be. Okay. So this is basically just one large JSON document. What do you suppose this first key and value pair represents? Yeah, or so, and what would the equivalent of this be in a relational database? What I've highlighted in gray. What is that value representing? You're on the right track with an access token. What would be the equivalent in a relational database of this? Yeah, it's a primary key. So we still want to have, and the data type is an object ID in MongoDB. So we want it to generate as an access token a unique value for every record. So within here, we have a whole series of other nested structures, right? We have an address that rather than having a single value, well, the address is its own nested array with all of the values pertaining to the address. And notice here, we even have a one-to-many relationship. So this looks like a restaurant rating. Here's the information about the restaurant. But then within here, we have grades, plural. So normally in a relational database, we'd have a restaurant table, we'd have a grades table, and they would be related, right? Every grade would be attached to a restaurant ID. In a sample MongoDB document, it's all stored together as one giant cluster, which means looking up the restaurant and finding the grades is really fast because we don't need joins and we don't need to travel different places in our database to get the data. It's all here. So we do have a unique field that will always be called _ID. MongoDB does this automatically. We don't have to generate it. We don't even have to say we want it. The database will do it for us as soon as we insert anything into it. One of the other nice things is this data is also fairly human readable. JSON format's easy to read. We can look at this and we can understand all of the data and all of the relationships in a really simple way. We don't have to write SQL queries. We don't have to set up keys. We don't have to do joins. So why MongoDB as opposed to other? There are some other popular no relational databases. CouchDB is one of them. This is the world's most popular. Where does the word come from? It comes from the word humongous. Notice in the middle there, you've got the word Mongo. So the idea was we could build big data stores quickly and easily and in a flexible way. Now in the video, we see the data, or in my sample, the data is stored as JSON. It's actually a different form of JSON called BISON, which basically stands for binary JSON. So it's taking JSON objects and just converting them into binary code, ones and zeros, to make it run even faster. Okay. And it works great with Node and Express because our application code is already in JSON, right? We've already seen this when we want to pass data from our controllers to our views, we're already using JSON arrays. So if that JSON array, and I think Connor, I think you asked that question last week, right? How would we pass data from a database? Well, it's great because when we query our data, it's already in JSON format. We don't have to convert it or do anything. We just run a query, store that result in a variable, and we can pass that variable right back to our view to display. So that part's really easy. Okay. Pretty much any place that will support Node will support MongoDB. The other option that we have for running our Mongo databases in the cloud, and I think I encourage you to get an account here, is MongoLab. So they basically give you half a gig of free hosting of a MongoDB database. They don't do the application end, they only do the database server. So this works well, for example, with Heroku, because Heroku will host our app, but Heroku doesn't run. If you want to run MongoDB here, they charge you as an add-on. I think it's $18 a month to run a MongoDB here. However, we could run our MongoDB here for free for up to 1 gigabyte. So our web application can live here and our database can live here. I think with Azure, I haven't looked at it for a while. I'll have to double check. I think Azure includes hosting MongoDB. And if it doesn't, then it can still connect to Mongo Lab as well. So I would encourage you, if you don't have a Mongo Lab account, you don't have to have one for today, but you should set one up. You will need it later in the course. Also, the syntax is super easy. No more SQL commands. Now, we didn't use SQL when we did ASP.NET in the entity framework. We used that sort of funky link syntax. The node syntax for working with Mongo, actually, sorry, it's the Mongo syntax itself, is even easier. So let's say we have a posts collection because we have a blog. We want to query that. We would just type the command db.post.find. And then if we put in no parameters, that would select everything. If we did this title : Mongo, that would be the equivalent of saying, you know, select star from posts where title equals Mongo or title like Mongo. So it's really simple syntax, and even our parameters are passed in again in JSON format. So we should run it. We can get it running locally. So you can download and install MongoDB for free on your machine. You just go to mongodb.com. You can run it in the cloud at Mongo Lab. I would encourage you to try both. Today, I'm just going to run locally off my local MongoDB. Later on, we'll set it up on Mongo Lab, or we can enable it on Azure. So if you go to mongodb.com, again, this was in the email I sent you back in January, sorry, mongodb.org. I asked you to download and install it. So it is a bit, I think it's about 65 megs. So you will want to download and install it. We'll start using it soon. So it's self-contained. So you can run it from anywhere. It doesn't get installed into your program files directory on Windows or into your applications directory on Mac. When you download it, do I have it here? Here's what you get, where I put it inside. I'll show you where I recommend you put it. So this is basically the entire application. So the main executable, we basically will run it from the command prompt. There's the two that we need, this MongoD, that's our local database server. When we start that application, MongoDB is running on our local machine, and we can create and manage those databases. And then we also have this Mongo, that's a command line tool that lets us execute commands against our database. So doing create, read, update, and delete. So we'll play around with these shortly. So download the application. Actually, when you run the install, it may put them in here. It may actually, maybe I was wrong. Maybe it does put it in your applications folder. Or yes, on Windows, it will put it in your program files, MongoDB. And then server 3 bin. So this is where, when you run the install, this is where all those files will go. So what I suggest you do to make this process easier, because we'll want to browse into this path from the command line. This path is a bit of a pain. So what I would suggest you do is go into this directory. So on your, if you're a Mac user, it'll just be in the applications directory, I believe. Applications, MongoDB. So if you go in there and browse all the way into the bin folder, you should have all these files. So just highlight everything and we'll copy them. And what I'm going to do is inside of my node directory, what I suggest you do is make a new directory here, call it MongoDB, and paste them in here. You don't have to do this. It's just because when we're browsing to the command prompt, this path is easier to get to, right? Because when we open a command prompt, sorry. Yeah, where did I put it? So inside of my, users. So the same place we've been doing all of our node stuff. So make a MongoDB directory and paste it here. Because this way, when I open my command prompt, I can just go cd, node MongoDB, and here's my application. So it's easier to run from here. So optional step, but will save you time. We're going to create one other directory. By default, when we start the MongoDB server, it wants to create databases in a folder called data. That's the default. We can override it, but the easiest thing is for us just to create a folder called data. And MongoDB will create databases in there. So inside of your node folder, once you've got a MongoDB set up and you've got your application copied, also just make an empty directory called data. You don't have to put anything in. Here are some of my, I created a database called test. So these are the files that MongoDB will generate. So it can just be an empty directory. You don't have to put anything, shouldn't have to put anything in there. So once you have your MongoDB and your data directory inside of your node folder, so what I want to do is I'm going to run this application, this MongoD.exe. That is actually the server. That will start MongoDB running on our machines. So here's how we launch it. So if I type the command MongoD, don't hit enter yet. So MongoD, that's the server. And then we'll put in --db path. But now we have to tell it where that data folder is. And it will generate a database in there. So that folder will be C, users, your username, node, and data. So start the server, and that's the path where the database will live. So now I can hit enter, and it should get a whole series of commands running, and my command prompt will be locked. Just like when we launch our node application, our command prompt is then locked. We can't do anything else while the server's running. It will be the same here. So I'll hit enter. Tells me finally my server is running. So the last thing it prints in the console is waiting for connections on port 27017. That's the default MongoDB port. So just like the default port for Express is 3000, the default port for MySQL is 3306, MongoDB runs on 27017. We can change it if we want, but there's no real need. So the command prompt is locked here. I want to leave this command prompt. I can't do anything. If I do anything here, I have to stop my server, and I want my server to be running. Yep. Yeah, the path will be. You know what? It may be easier to install on a Mac. I haven't done this for a while on a Mac with Homebrew. I think that would be better. There is a good tutorial that I haven't seen for on how to do this. So here's installing MongoDB on OS X. So I think they're going to recommend using Homebrew. Yeah, so through the command prompt with Homebrew.
You'll have to install Homebrew first.
You do have to install Homebrew first. The link to Homebrew is here, though. So if you go to, it's under docs.mongodb.org and under installation. So if you go to installation and install the community edition here, there are the instructions to install it on OS X. So you'll want to install Homebrew. And then, so the link for Homebrew is here. This is a useful package for you to have anyway, not just for installing MongoDB. Your other option is you can just use Mongo Lab if you want. You don't have to run it locally. You can just run it online and connect to Mongo Lab. It accepts remote connections. That's another option.
So you install Homebrew in Node?
No, Homebrew is not particular to Node. It's for just installing a whole bunch of other packages that are useful that OS X doesn't have. So it's just a general OS X tool. So you can use it for installing other things as well. So install Homebrew. And then once you have Homebrew installed, you use the brew command. So you do a brew update and then you install MongoDB. With brew install MongoDB. Now you can do it this way if you want. You can, this is how to do it without Homebrew. But they don't recommend, they say only do it this way if you can't get Homebrew to work. That's straight from Mongo's own documentation. So once your server is running, we can now interact with this database. I'm going to leave this command prompt up and running because as soon as I close it, I've killed the server. So I'm going to open a second command prompt. I will go into my node MongoDB folder. So if I run the list of commands, what we want now is the Mongo. This basically will allow us to run queries against the database or do any kind of create, read, update, and delete. So if I just run the command Mongo, by default, it connects to my local server. If I want to connect to a remote server, I would have to put in what remote server I wanted. And it says we're connected to a database called test. If you go and look in your node data directory now, you should have a file called test.0 and test.ns. So those will be basically your database shell that comes automatically as soon as you run a local instance of MongoDB. So what we're going to do is build a collection and put some documents in it. And the nice thing is we can basically insert the data right away. We don't have to build the collection first. If this was a relational database, first we have to build the table and then we have to insert data, and the schema of the data has to match the schema of the table. That here. We can just dump some data in and MongoDB will automatically generate a collection for us. So if we want to use a different database, we would just run the use command like we would in MySQL. And that would actually generate another database. So you don't have to do this, but just to show you, use another DB. If I run that command, it says it switched to another database. So now I could run commands in here if I want. If I want to go back to test, which is there by default, I'll just work with the database called test. So we want to dump some data in here. So I've given you on Blackboard, here's a script. This is how we would insert 3 documents. So we're going to create a collection called articles. And we're going to insert 3 documents. Each one has the same scheme. It has a date created, an article title, and some content. And notice each one of these is just a JSON array. So I'm going to copy that script. So just highlight those 3 lines on Blackboard, copy them to your clipboard, and you can see the syntax. db.articles will be the name of the collection, .insert. So I'll go back to my Mongo command prompt, paste those in. Now notice, as soon as I pasted the first 2, it already inserted, and it says inserted 1 record after the first 2. I just need to hit enter to run the 3rd one. So now I get 3 messages that say N inserted 1. So we didn't even have to build the collection first. We just put the data in and the collection is built on the fly. If we want to see what's in here to run a query, the command we'll use is db.articles.find. This is the SQL equivalent of running a select star from articles command. If I hit enter, this looks a bit messy. So we can see we inserted created the title and the content, and MongoDB automatically generated these access tokens, as Vadim called them, which isn't a bad way of thinking about it, or this _ID field. The data is a little hard to read. If we want to make it more readable, I can run that same query, db.articles.find, and there's another built-in function into Mongo called pretty. This will format as JSON the output, so it's more readable. So I'm running the same query, I'm just adding on .pretty on the end, and now it wraps the lines and indents, and we've got a JSON array. So this is in some ways a good deal easier than working with most relational databases. We don't really have to plan it out and build the database first. We don't have to worry about relationships. We just start throwing data in the thing, and it collects it all. I may have duplicates in my table. That's okay. So what to go? So these instructions are here. I'll update. All these instructions are here. So you notice it's running on port 27017. So all these commands are here. Notice also, if we wanted to, we could insert documents into the same collection that have different schemas, if we wanted to do that. So we've used the .find.pretty to run a query, and we can see this object ID. So we've got the find, we've used the insert method, we've used find. We have an update method. We also have a neat method called upsert. Anybody have an idea what upsert might do? Okay, so how would it be different from update? Mallory, did you have an idea? What do you think upsert might do? It's very handy. Okay, you're getting warmer.
If it's already in the database, it'll update it, but if it's not, it'll just insert it.
Absolutely, exactly. So rather than checking, does this record exist? And if so, we should update it. If it doesn't exist, we'll do an insert. The upsert method does that automatically. It will first check, does this document exist? If it does, it updates. If it's not found, it inserts. And we also have to delete, we just call remove and pass in any parameter to indicate which document we want to remove. We can also specify how many records we want to remove with update. So those are our basic methods we'll be using. Find, insert, update, remove. Pretty self-explanatory, easy commands that will perform our 4 CRUD operations.
There's no like defined table structure. Is there any like specific like naming conventions or anything so you don't like a bunch of different ones? Or?
That's a very good question. Typically, what's used is, let me just go back here. Certainly, I think we're going to use camel case for naming of our keys, but other than that, not particularly. There aren't sort of strong rules. We'll just sort of follow, so the naming sort of matches things, how we're naming things within the Node application is fairly typical. So camel case would be one thing that we can expect will be fairly normal. There aren't a whole lot of rules around that, however. Okay, so there's our database backend. We've created, we've basically done everything we need to do here. We've built a table and we've put some data in it. So now we should be able to make a Node application with Express, the generator, to pre-build out. And then we want to start getting our Node application to actually talk to our MongoDB. So the way we do that in our PHP applications, we used the PDO library, right? PDO is an interface for allowing a PHP application to talk to a database. In ASP.NET, we used the entity framework. It was that object relationship mapper that allowed our .NET application to talk to us. Well, we used it for SQL Server. We could have used entity framework for talking to other things. In Node and MongoDB, the interface is called Mongoose. So Mongoose is an NPM package that we can use. So we can kind of have a look over at NPM. We'll take a pause in a minute before we get into Mongoose. So it's going to be really widely used. I will bet we will see hundreds of thousands of installs. Yeah, almost 1 million, 750,000 downloads of Mongoose in the last month. So basically, if we're building a mean stack application, we're going to be using Mongoose as that interface to let our Node and Express application talk to our MongoDB. So we will be using this basically every week from now forward. Our application will be talking to our MongoDB database, and our applications are going to require the use of Mongoose. Okay. So what we're going to do, we're going to take a pause here. When we come back, we're going to build a lesson 6 application. We'll use the Express generator to pre-scaffold it out for us. And then we're going to add Mongoose in and start building. We said back in last week, once we were using Express. So last week, our lesson 5 application, your lab 4 in your portfolio, you're all kind of doing this piece where we have the client, the dispatcher, the views, and the controllers. This part was left out. So this week, we're going to add in the model. This is where Mongoose is going to come into play. We'll add in Mongoose, and we'll create our data models so that our controller can also talk to our MongoDB. So we can do create, read, update, and delete. So in the next hour, we should be able to at least read data out of our database, if not do create. And then next week, we'll be able to do update and delete, as well as whatever we don't finish today with the create process. So we will take a pause for 10 minutes here, and then we'll come back and integrate our MongoDB.